Hello everyone, I hope you guys are doing good. So today we'll be discussing another problem of a blind 75 series. So the problem of the day would be counting bits, problem 338 Leetcode. So in this given problem, we have been given an integer n and we have to return an array answer of length n plus 1 such that for each I in the range of 0 to n, the answer of I or the ith position and our array answer is the number of ones in the binary representation of I. So let's say, for example, we have been given n equals to 5. So our answer would contain the number of ones we have in the binary representation of 0, 1, 2, 3, and 4. So we would just look at these binary representations and we will put 0, 1, 1, 2, and 1. So this would be a sample output for a sample input n equals to 5. So to solve this problem, we would be looking and trying to find a pattern in the given problem. So here, as we can see, we do have the binary representations of integers from 0 to 8. So the first thing that we notice over here is the number of 1 bits at every integer that's a power of 2, like 1, 2, 4, 8, 16. The number of 1 bits in these integers is always going to be 1. You could easily find this here. 1, 2, 4, and 8. So the next part that we would like to notice or would like to find in this pattern is we can observe that the number of 1 bits at integers that are not a power of 2 is equal to 1 plus the number of bits, which bits? 1 is equal to the 1 plus number of bits of the integer that was at a position I minus the last integer that was of power of 2. So let me explain you this with the help of dynamic programming. So we would consider an array dp which would have initially n plus 1 zeros. Let's say and now what we have to look is the first thing that we noticed was for every integer that is of the power of 2, the number of 1 bits were equal to 1. The second thing we noticed was that the number of 1 bits at any integer I is equal to 1 plus the number of 1 bits at integer I minus offset. So what's this offset? Offset is the recent power of 2 that we have encountered when we are traversing our dp from 0 to n plus 1. So when we start traversing our dp, we know that for 0, we will only have 0 bits of 1. We will only have 0, 1 bits. So moving on to the next integer 1, we know that 1 is 2 to the power 0. So for this case, we would have 1 bit. For 2, as we know it's 2 to the power 1, we know it would have a single 1 bit. So for 3, what we would like to observe is, as 3 is not an offset value, or I should say is not an integer that is to the power of 2, the way we would find the number of 1 bits in these type of integers would be 1 plus the number of 1 bits and our dp at I minus offset. So I know this is kind of confusing right now, but it would just start to make sense when we move to these examples. So it would be 1 plus the value of dp at I, that is 3, minus the recent offset 2. That means we have to go here and add 1. That means 2. For 4, as we know, this is the offset value, or a power of 2. Our new offset value will be 4. So for 5, the value would be 1 plus dp of 5 minus 4. That's equal to 1 plus dp of 1. dp of 1, as we can see, is 1. So we just add 1 and it would be 2. And we see it's matching. Now, we would also update the values of dp3. That was 1 plus 1, 2. For dp4, it was 1, as it was an offset value. This is 2. And now for dp6, it would be similar. 1 plus dp6 minus 4, or dp2. dp2 was 1, so it's 2. Again, it would be 1 plus dp3, which would be 1 plus 2, that's 3. And again, for 8, as we know, it's an offset value, we'll again start from 1. And again, our offset value would be increased to 8. And similarly, for 9, we would solve for 1 plus dp 9 minus 8. Then similarly, 1 plus dp 10 minus 8, until we reach our next offset value, that would be 16. So let's look into the coding of a given problem. So the first thing we need to maintain is our answer. That's just the dp array that we discussed, as the question asks us to provide us with a array answer. We would just use answer, and it would be of length n plus 1. We will have our offset value, which would be the first integer that is to the power of 2, or 2 to the power 0, that's 1. After that, we will just run through a loop for I in range 1 to n plus 1. As Python does not include the last integer, we will just go from 1 to n. And we would first check if offset into 2 is equal I. If this is the case, we would just update our offset value to I. Other than that, the only thing we need to do is we need to update the ith value of our dp of our answer array as 1 plus answer of I minus the offset value. And we would just have to return our answer array. Let's look into the solution of our problem. As we can see, this is a pretty efficient solution. And talking about the time complexity of a problem, it would just be big O of n, as we are only traversing the array once. And talking about the space complexity of our problem, it would also be bigger of n, as we are using an array to store n different values. I hope you like this video. Have a good day. Thank you.